So we're in chapter 2 on fractions, and section 1, we're going to focus now on prime numbers. Okay. So prime numbers are really important when it comes to working with fractions, so we can understand really the structure of the denominator of the fraction, the number that's at the bottom. Okay, so this is really important in terms of foundation around that. So a prime number is a whole number with exactly two factors, 1 and itself. I'm just going to put an example of a prime number here, 7, which is just 1 times 7, and no other numbers, no other whole numbers go into 7, 2, 3, 4, 5, 6, okay? A composite number is a whole number with more than two factors. So we might think of, say 6, right? So 6 can be written as 1 times 6, but you can also write 6 as 2 times 3. So the factors of 6 are 1, 2, 3, and 6, and that's more than just 1 and 6. So 6 is composite, and 7 is prime. And just a note that 0 and 1 are neither composite or prime. Okay, so we're going to just go through some numbers. I wrote out the first 20 numbers, the first 20 whole numbers, and I want to circle the prime numbers and start to get a feel of what numbers are prime and what numbers are not, so that we can be real comfortable when we go look at the denominators of fractions. Okay, so I noted here that 0 is neither prime or composite. So I'm gonna get, 0 and 1. So I'm gonna cross out the 1. So if I think about 2, and I think about all the ways that you can write 2 as a product of numbers, I note that 2 of whole numbers, that 2, right, is 1 times 2, and there's no other ways to write 2. So 2 is in fact prime. I'm going to circle the primes and cross out the composites. Okay, so we'll kind of like make accumulating primes. When I look at 3, I say 3 is 1 times 3, and there's no other numbers that go into that whole numbers. Like 2 does not go into 3, does not divide evenly into 3. So 3 is also a prime number. But when I go to look at 4, right, so 4 is not prime, because I can write 4 in another way other than just 1 times 4 as the product. So 4 is not prime. 5 is prime. The only products of 5, the only factors of 5 are 1 and 5. 6 is not prime. 2 times 3 equals 6. 7, we already discussed that 7 was prime, because 1 times 7 is 7, nothing else. Notice now that I'm going to cross out the 8, right? Because all of the even numbers are not prime because 2 goes into them. So I can cross these out all at once if I want to get through, like finish up the video quick. We'll be able to think about the numbers a little more quickly. All right, so all of the things I crossed out are not prime because 2 goes into them. 2 times 10 is 2 times 5, etc. So 3 is not prime because, 9 is not prime because 9 equals 3 times 3. So 9 is not prime. 11 is prime. Okay, 13 is prime. You can go through all the rules if you like, but you should check and convince yourself. 15 is not prime because 15 equals 3 times 5. So not prime. 17 is prime, 19 is prime. Okay, so 17. So my prime numbers, my first few prime numbers are, I'd like you to write the first few prime numbers on the front page of your notebook or in the back of your notebook, somewhere where we can just quickly look and catch them. We'll be doing a lot of prime number checking. So I'm just going to list the prime numbers that we found. Okay. Maybe if you can go ahead and think through a few more. 20 is not prime, 21 is not, 7 times 3, 22 is even, 23. All right, so I'd like you to finish up, get the prime numbers less than, I don't know, 35 or 40. Okay. And so the next thing I want to do here was we're going to use the prime numbers. We're going to write what's called a prime factorization. So a prime factorization is when you find all the prime factors of a number and write that number as the product of those prime factors. And I will put an example on the board here. Right, so let's look at this nice big number 90, right? And what we're going to do is we're going to factor out, we're going to consider the smallest prime. So we check the smallest prime, which is 2. Does 2 go into 90? It does. This is 2 times 45. Okay, great. So we now want to see whether or not 45 is prime. So we're going to just, if it is, we'll stop and we'll have our answer, but otherwise. 45, does 3 go into 45? Does 2 go into 45? No, because this is not odd. The last digit is not odd. But 3 does. And 3 times 15 is 45. And I used the sum of those digits was 9. That gave me the clue. And I ask again, 15 does, the 2 doesn't go into 15, but does the 3 go into 15? It does. So that's 3 times 5. And now I look at the larger number here, 5. And 5 itself is prime. So we have now completed the prime factorization. So what I'm going to circle are the prime numbers. I want to write this as 90 is equal to 2 times 3 times 3 times 5. Okay, that is a prime factorization. You can also write this 2 times 3 to the second power times 5. All right. So that's my prime factorization. We will pick up the next topic in the next video.